Intermediate Algebra Section 3.3 Solving Applications. We're going to take a look at a distance problem here that involves the idea of current. And in this case, we're talking about a problem with a river. This also can be problems that we see when we talk about airplanes or jet travel, where we have tailwinds or headwinds that increase the plane's speed or decrease it. Here we're looking at the river's current having an effect. So let's read the problem. Ben paddled for 3 hours with a 5 km/h current to reach his camp. The return trip against the same current took 6 3/4 hours. Find the speed Ben paddled in still water. This is definitely a distance problem, so to help us organize the information, I've set up a table with the components of a distance formula. Rate times time equals distance, and they're asking us to find the speed of Ben paddling in still water. Think of this as though he were canoeing on a lake. So we'll let our variable represent that unknown. So x will be Ben's still water rate. So the first part tells us that Ben paddled for 3 hours with a 5 km/h current to reach his camp. With the current, that means he's going downstream. And downstream, his speed is going to be enhanced by the current's speed. So his rate with the current will be his still water rate on the lake, but because he's going with the current will actually make him go faster. They will combine, and it tells us that it took him 3 hours. We could multiply the rate times the time to give us the distance then that he traveled to get to camp. The return trip against the same current, so now he's returning, and that current is dragging his speed down. He's not going nearly as fast. If a viewer was on the shore, they would see that his current or still water rate would be reduced by the current or the speed of the river, resulting in a representation of his speed against the current as x minus 5. And it's telling us that it took him 6 3/4 hours, or decimal equivalency 6.75. Rate times time, we can fill in our last cell here in the table. And to generate an equation then, he's going from camp to his launching, so the distance with the river will equal the distance against the river. The distance with the river, or the current, from the table we found to be 3 times x plus 5. Going against the river, or current, is 6.75 times x minus 5 for the distance. We now have our equation. It has one variable. Simplifying first, using distributive, we'll eliminate the parentheses, so 3 times x and 3 times 5. 6.75 times x on the first, and 6.75 times the negative 5 results in a 33.75. Getting our variable on one side, we'll subtract a 3x from each side, leaving a 15 is equal to a 3.75x minus 33.75. We have the variable on one side. Let's get the constant terms together. So to undo a subtraction, we'll add 33.75 to each side. 15 and 33.75 is a 48.75 is equal to the variable To get the variable by itself, undoing the multiplication so that we have a coefficient of 1, we'll divide both sides by 3.75 to give us x of 13. X is Ben's still water rate. In other words, if he was just canoeing on a lake, he can paddle at a rate of 13 kilometers per hour. And are we answering the question? It asks us to find the speed Ben paddled in still water. So we have answered the question with our variable. And of course, we would always want to make sure that we've answered the question correctly. We're good there, but plug that value in, replace the variable with 13, and verify that all things do work out correctly.